In this video, we're going to continue topic 8.2, and we're going to be looking at example 13. So sometimes the questions are going to ask us whether an object is moving or a particle is moving towards the origin or away from the origin. So if we get the position and the velocity, and we know that the values of them are opposite signs, we know that they are moving towards the origin. And we know that if they are the same sign, that they're moving away from the origin. So in example 13, we have a particle and it gives us the position and it wants to know when the particle is moving towards the origin. So the first thing I need to do is I need to find some critical numbers. I do need to find some intervals where that is equal to 0. So I'm going to just start by taking my position and I'm going to set it equal to 0. I'm going to come up with some critical values. So I know I would have to get out my good old magic X. I need two numbers that multiply to 24 and add to -10, and that would be 6, -6, and -4. So I would have t minus 6 times t minus 4 equals 0. So I know that those values would be at 6 and 4. I also need to know where the derivative is equal to 0, so I can get, because that's where my velocity comes from. So velocity is the derivative of the position, which is going to be 2t minus 10 equals 0. And so 2t would equal 10, so t equals 5 would also be a critical number. And the key to this one is getting out a sign chart. And we're going to do a double layer sign chart, just like we did when we were doing curve sketching. So we've got 0. My first critical number is at 4, draw a fence. My next critical number is at 5, draw a fence. My next critical number is at 6, draw a fence. And then I guess it goes to infinity. And then we want to know what's going on at the position, x of t, and the velocity, v of t. So I'm literally going to plug into the most simplified version of that. I'm going to start here. Oh, do you know what I meant to do first? I'm going to pick a t value first. Then I'm going to go into x of t and v of t. All right, so the t values, I'd pick something between 0 and 4. I'd probably pick 1. Between 4 and 5, I'd have to pick like 4.5. In between these, 5.5. And then I'd probably pick 10 here. So I'm going to go into the most simplified form of my derivative right here. I'm going to do all of my x of t's first. So I put a 1 into this right here. I'd get a negative, and into that I'd get a negative. Negative times negative is positive. 4.5 into this one, I'd get negative. 4.5 into that one, I'd get positive. Negative times a positive is negative. 5.5 into this one, I'd get a negative. 5.5 into that one, I'd get a positive. So a negative times a positive is negative. Put a 10 into this one, positive. 10 into that one, positive. Positive times a positive is positive. All right, let's look at our next one. So now I'm going to be substituting into here. I'm going to put a 1 in. 1's going to be a negative number. 4.5. So that'd be like 2 times 4.5 would be like 9, right? So 9 minus 10 is still going to be a negative. Then I'm going to put in the 5.5 into there. So 2 times 5.5. We know 2 times 5 is 10, so it's got to be greater than 10. I know that's horrible notation right there, so it's got to be positive. And then I put a 10 and it's definitely going to be positive. So what I'm looking for is where are my signs opposite, because we were supposed to be finding a moving towards the origin, and towards the origin is opposite signs. So it looks like it's happening on the interval from 0 to 4 and 0 to 5. So we just need to write that in a sentence. So the particle is moving towards the origin on 0 to 4 and 5 to 6, because you always have to state why, because they're going to ask you to explain it, because x of t and v of t are opposite signs.